let's go ahead and jump right into it. For the first question, you have an A, B, and C, and this is asking you to identify the following exponential functions as exponential growth, exponential decay, or neither. So what you're going to do is you're going to look at two different things. You're going to take a look at your B value. Your B is your base. So I have a B value of 1/6. Then you're going to take a look, and if there is a negative on your A value, this negative represents a neither. So this is neither growth nor decay. Let's go ahead and take a look at number 2. For number 2, again, we're going to take a look at the B value. Then we're taking a look at the A value. And if the A is negative, it is going to be neither growth nor decay. Now, the reason I am looking at B value before I'm looking at A is because sometimes we get something like this. And if I look at my B value, I see a 2. 2 is greater than 1, which would indicate a growth. Since there is no negative in front, A is not negative, that means that we have exponential growth. Now, this one here would indicate, because it's between 0 and 1, that it would be a decay. But again, when we have that A value that's negative, it becomes an neither. Same thing here. Because our base is between 0 and 1, it would technically be a decay. But because our A value is negative, there is a reflection across the x-axis, which makes it a neither. For number 2, identify the asymptote in the following functions. This needs to be in the correct format. Asymptote is an equation of a line, so all of these are going to get a y equals. Now, your asymptote is your k value. Now, you want to make sure to take it with the symbol. So if I see a -8, I take a -8. If I see a +4, I take a +4. Now, what about something like this? Notice we have a 3, and that 3 is with the x as an exponent. And the k value is what is after the exponent. Notice we have an exponent, we have a k value. We have an exponent, we have a k value. If the k is missing, and we don't have a k value, that means our asymptote is at 0. So we still do have an asymptote, it's just 0. When it's asking you to describe the transformation of f of x, that means describing in English. So we're going to have some sort of numbers in a particular position, and each one of them needs to be described in an English way. So if we take a look at the first A value, your A is between 0 and 1, which would be a vertical compression. And be careful here because you have to tell me by how much. If I'm squishing slime or pressing down, I need to know how far down. So this is by 1/3. Next, we're looking at the B value. B is greater than 1. This is growth. But remember, we have to always look at the A value. If the A value is negative, that means it would become a neither. Since our A value is not negative, then we stay with growth. Next, we have our H value. H is opposite of what you see. So I see a -2. That means I go to the right 2 jumps. K is for keep. I see a -1. That means I go down 1. Okay. Moving on. Question number 4 is 2 parts, A and B. The first one is asking, well, both of them are asking, does the table represent an exponential function? Explain your reasoning. So it's kind of a 2-part, yes or no, and then you have to have your explanation. So if you take a look at these tables, they are vertical tables, so up and down. I'm going to transform these into horizontal table. So we got 1, 2, 3, 4. Here we have a 3, a 7, 11, and a 15. You can notice that your x values are all increasing by 1, so it does have a consistent pattern. And so our focus is going to be on the y values. Now on these y's, you're going to figure out if the pattern is exponential. To find out if something is exponential, exponentials have something that's called a common ratio. Common ratios are when you take your right number and divide it by your left number. And notice that we have multiple numbers, so I'm going to cover this 3. My 11 is now my right, and my 7 is now my left. So we got 11 over 7, and then lastly we got 15 over 11. Always you want to do the right divided by your left. If these give us the same value, 7 divided by 3, I get a 2.3. 11 divided by 7, I get a 1.57. Now, I understand these are decimals. Typically, we say no decimals. I'm just showing you how these are not the same thing. Not common. If it was common, then we can see what the fraction is. But for us, I'm trying to figure out, do we have something that's common? When I divide my right number by our left number, do we have something that's common? Not common. So, is this an indication of an exponential function? No. Not an exponential. Okay, and it says, state your reasoning. What's the reasoning? No common ratio. So my answer for this table here is this an exponential? No, it is not an exponential. Why is it not an exponential? Because there is no common ratio. Common ratio is also known as lowercase r. Let's go ahead and do exactly the same thing. I'm going to push my table over so I can get my right versus my left. 1, 2, 3, 4. You can see that we are increasing on our x's by 1. So it is a pattern here. Sometimes there isn't. And so now we go 6, 12, 24, 48. Take your right divided by your left. Take your two numbers. So we got 12 divided by 6. Again, cover this up. We have two numbers, 24 and 12. And 48 and 24. We have 12 divided by 6, which is 2. 24 divided by 12, which is 2. 48 divided by 24, which is also 2. So notice here, we do have a common ratio. So our r is 2. So is this table representing an exponential function? This table, yes. Exponential. Because it has a common difference. Oh, and I said common difference, which is incorrect. Common ratio. All right, let's move on. Question number 5 is going to be your first question. You will have 2 questions. For graphing, this is something that needs to be done without a calculator. So for us, we're going to be looking for 2 different things. We're going to be looking, do you know how to handle or deal with a negative exponent, and do you know what exponents are? So first thing you're going to do is you're going to take your function, the function that they give you. For us, it is 1/5 to the x minus 2 power, and I'm going to copy this down, and I'm going to create a little opening for my x value. So I'm just copying, nothing changes here. I'm going to then write in my x value, so I have a -2, -1, 0, 1, and 2. Now, in this step, I'm not going to do anything with the 1/5, but I am going to calculate simplify, subtract just the exponent spot. So I have -2 minus 2, so that means we got 1/5 to the -4th power. -1 minus 2, that's 1/5 to the -3rd power. 0 minus 2 is 1/5 to the -2 power. 1/5, 1 minus 2 to the -1st power, and 2 minus 2 is 0. After that, I'm looking, do you know how to handle or deal with that negative exponent? So we're just focusing on the ones with the exponents. When you have the negative exponent, we're going to flip the base. So this 5 becomes, this 1/5, excuse me, becomes a 5 over 1. This 1/5 becomes a 5 over 1. Now notice my exponents are now positive, 5 over 1, and my exponent is positive. Here, again, we also have a negative. So that means I flip the base, only flip when the exponent is negative. 0 is not negative, so I do not flip the base. Next, I'm going to see if you know what an exponent means. So for us, I want to see 5, 1, 2, 3, 4 times, 1, 2, 3 times, 1 twice, once, and anything to the 0 power is 1. Next, we're going to evaluate. Here we just have 1, so we're going to bring 1. Here we have 5, we're going to bring 5. 5 times 5 is 25. 5 times 5 is 25, times 5, 125. And then we have 5 times 5 times 5, which means 25 times 25, which means we have a very large number of 625. Now, I'm not expecting you to graph things like 125 and 625, even 25. I don't have space here, but I'll show you how to deal with something like this. What is the asymptote? Okay, so let's go back. This is like question number 2. I'm going to go back and look at my K value. Your K value is your asymptote. And the value that we have for K for our asymptote is no value at all, which means that we do have a secret 0 here to show for our asymptote. So asymptote needs to be y equals, and for us it's 0. I'm going to wait on domain and range. Let's graph it first. I feel like domain and range is easier shown on a graph. So let's start with our asymptote. Asymptote needs to be a dotted line. Now some of you are writing in pencil, which is good, but pencil is very difficult for me to see when I'm grading. So your asymptote needs to be a dotted line, and it needs to be way past what is given. So here's my given graph. I'm noticing that I have something here and here. That way I can actually see it when I'm grading. Otherwise, I won't see it and I will not give you credit. Next, let's go ahead and graph the points that we can. So that means over here, I have an input of 2 and output of 1, an input of 1 and output of 5. Maybe I can guesstimate where an input of 0 and output of 25 is. We shall see. Let's go to start with 2 and 1, 1 and 5. 1, 2, 3, 4, 5. So you can see that if we were to do 0 and 25, 0 and 25 we can guesstimate could be somewhere over here. If we were to connect these, there'd be a kind of a curve, and now we're going to be approaching the asymptote. And I want to be very clear here, do not touch the asymptote. Think of it as lava. So I'm a little off on my dot, so I'll make the dot a little bit bigger. But yes, do not touch the asymptote. You want to approach it half of an arrow, and then you want to go up. So you can see we're going down, so this is called exponential decay. And we know this is going to be a decay function because if we go back up here and look at our b value is between 0 and 1. So that means that we will have a decay function. Now let's talk about domain and range. Domain, no matter what your function is for an exponential, doesn't matter if it's growth, it doesn't matter if it's decay, or neither, Domain is always going to be the same. You're going to go open parentheses, negative infinity, comma, positive infinity. These are all of your possible x values. So we can do any x that we want from the negative x's to the positive x's. That part doesn't change. It won't change. Now for range, range will change. Again, so domain doesn't change. So domain's always going to be the same thing. For range, range will be dependent on your asymptote. So it will change with every function that you do. So this is dependent on the asymptote. Because we have a limitation on the y's, we can go only this far up or this far down. We're going to start with the lowest number it can be. So start with your asymptote or end with your asymptote. Depends if you have a neither, a growth, or a decay. The smallest value that I'm approaching is 0. So I'm going to open up with 0. And then if you notice that we're going up, 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 all the way on our y, so we're going to go up to a positive infinity. Parentheses for both. You cannot grab a hold of infinity, so we open parentheses. And because our asymptote is 0, we can't actually have 0. It is a number that we are approaching. Okay, let's go ahead and move on. Okay, let's go ahead and do the second one. It's going to be a little bit different, but relatively the same. We're going to start off by copying down the function here. And we're going to copy and paste, copy and paste, copy and paste. So we have 4, open up for x. Now I want to be a little extra with my 2 because 2 is not part of the exponent. 2 is our k value. But you still want to open up a spot for your x's. And then we're going to put in our values for our x, which are -2, -1, 0, 1, and 2. Okay, next we have to evaluate the base in the exponent. There's nothing for us to do in the exponent spot, so I'm going to evaluate what 4 to the -2nd power is, 4 to the -1st power, and here you want to be careful with the negative. So I'm going to leave these two semi-highlighted and say, okay, well this is negative. What happens when I have a negative exponent? That means I flip the base. What happens when I have a negative exponent? I flip the base. What happens if I have a negative? Oh wait, this is not negative, so I don't flip the base. Keep it as it is. This one is not negative. This one is not negative. Don't forget your 2's. Okay, we're going to do equals. Again, we want to evaluate what it means to be an exponent. So this 1/4 squared means that I have a 1/4 times 1/4. We still have that -2. This is 1/4 once, -2. Anything to the 0th power is 1, -2. 4 once, -2. And 4 twice, -2. Working backwards, I'm going to go from down to above. 4 times 4 is 16, -2. We got, again, 4 -2. Here we just got 1 -2. I'm going to evaluate those before I deal with the fractions. 16 -2, we got 14. Bring that here. 4 -2, we got 2. 1 -2 is -1. Now let's talk about your fractions here. For the first one, we have, I'm going to split this in half. We got 1/4 -2. Notice that we have a fraction and a whole number, so we're going to need to rewrite this 2 as 2 over 1. This 2 is the same as 2 over 1. These are the same. Now that we have this 2 over 1, we want to get the same denominators. Notice I have a 4 and a 1. They're not the same. In order for us to add, subtract fractions, we have to have the same denominator. I'm going to multiply the second fraction by 4, top and bottom, numerator and denominator. And the reason being is once we have the same denominator, we can add, subtract them. So I have 1/4 minus 8 fourths. Copy the denominator. Denominator stays the same. Now for the numerator, you're going to have 1 minus 8, which is negative 7 fourths. This is what you're going to be writing here. Now we do have one more, and that is with an extra step, 1/4 times 1/4 minus 2. When you multiply fractions, please multiply them straight across. So we got 1 times 1, 4 times 4. Do not touch that 2, not yet. 4 times 4 is 16, so we got 1/16 minus 2. Now we're back here where we have to rewrite 2 as a fraction of 2 over 1. And we have to create common denominators. So we have that 16 now, so a different denominator, and we have that 1. So that means that I'm going to be multiplying top and bottom by 16. The 1/16 stays the same, minus 16 times 2 is 32, and 1 times 16 is 16. Again, we keep the denominator the same, so 16 stays. Now we have 1 minus 32, which gives me a 31 negative 16ths. And that goes here. Okay. Let's go ahead and shift this down just a little bit. Let's graph. Now things like negative 7 fourths, I don't necessarily know what that is off the top of my head. That's something that perhaps a calculator can help us, but I'm going to use the numbers that I do know. So I'm going to graph. Let's go back up here. I'm going to squeeze this in. I have 1 comma negative 1 here. Just kidding, that's a 0. Let's try this again. I have 0 comma negative 1. I have 1 comma 2, and I have 2 comma 14. Again, I don't have 14 on my graph here, but that's okay. I can try to guesstimate where that will be. Let's start off with our asymptote. What is our asymptote? Let's go back up here. Remember, our asymptote is our k value. And we do have a k value, so it's not 0. Our asymptote is at y equals negative 2. All right, so let's start with a negative 2 on our y-axis. So here's our y-axis. Let's drag down, down, down. Where's negative 2? There it is. Now you're going to show that asymptote as a dotted line going way past what is provided. And you have to put arrows because this line continues forever and ever and ever. And dotted because we don't actually see it. It is semi-invisible. Next, let's go ahead and graph the points that we have. I have 0 and negative 1, 0 and negative 1. I have 1 and 2. And I'm going to guesstimate where 14 is. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Maybe here-ish. I'm going to connect. And knowing that the exponential function is going to have a curve, I'm going to curve. Do not touch that asymptote. You touch that asymptote, it's lava. We don't want to touch lava. Here we have a half of an arrow. Here we have a full arrow. And we're going to be approaching this asymptote, but we're not actually going to touch it. This, since we're going up from left to right, is called exponential. Growth. Okay, so let's talk about domain and range. Remember, for domain, it doesn't change. We're always going to want x values from negative infinity to positive infinity, all the way to the left and all the way to the right. This is very specific to an exponential function. If you're talking about a linear function or if you're talking about quadratic function, things will change depending on which function you have. For an exponential, domain is always going to be the same. Now for the range, range is going to be different. Range depends on your asymptote. And if you take a look here, we have a negative 2, and then we go all the way up, 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 up to infinity. We always want to start with a smaller value. For us, our smaller value is negative 2, and we go all the way up to positive infinity. It doesn't always go up to infinity. If you have a neither function, then we can go down to a negative infinity. All right, let's go ahead and move on. Number 7 is asking us to determine whether the table represents an exponential growth function or an exponential decay or neither, and explain. This is not the same as question number, oh, which question was it? Question number 3, 4? 4. It's not the same as question number 4. Question number 4 is asking us, is it exponential? Yes or no? This is asking, is it exponential growth? Is it exponential decay? Or is it not even exponential? So let's take a look. Again, they're giving us vertical. Let's go ahead and push them down to a horizontal table so we know which ones are right and are left. And we're going to do exactly the same thing. We're going to look at our, kind of doing both at the same time, but we're going to look at our common ratio and determine if this common ratio is giving us a growth or a decay. Think of it as your B value. If B is greater than 1, then it will represent a growth. If B is between 0 and 1, it will represent a decay. So let's go ahead and talk. We got 12, 9, 6, and 3. Okay, take your right divided by your left. 9 divided by 12. Take your right divided by your left. 6 divided by 9. Take your right divided by your left. 3 divided by 6. We got 9 divided by 12. Decimals are not allowed, so second PRB gives us a fraction of 3/4. 6 divided by 9. Decimals are not allowed. This gives us 2/3. Okay. 6 divided by 3. Decimals are not allowed. Fractions. So in this one here, is this exponential? Do we have a common ratio? We have a ratio. We have fractions, but are these the same? No. This is not exponential. And this is it growth? Is it decay? Or is it neither? This is neither. It's not growth, it's not decay, it's neither. It doesn't even have a common ratio. Let's try the next one. We got 0.125, we got 0.5, 2, and 8. So let's do our right divided by our left. 0.5 divided by 0.125. Now this is requiring you to work with decimals, so you would be using a calculator on this. So right divided by left, right divided by left, right divided by left. Typing that in, 0.5 divided by 0.125. We have a 4. We have a 2 divided by 0.5. We have a 4. And we have an 8 divided by 2, which is a 4. Notice that we all have the same number of 4. That means we have a common ratio. Common ratio of 4. Now, the question is not asking us what the common ratio... Oh, you guys can't even see that. Is that better? That's better. The question's not asking us what the common ratio is. The question is asking us, is this decay? Is it growth or is it neither? So we're going to take a look at this common ratio. Imagine this is your B value. And remember, B is greater than 1. That means growth. So same thing here. Since our common ratio is 4, it's greater than 1. This is going to be exponential growth. Okay, we're almost done. Question number 8, this is asking us, a farm of 350 bunnies and a population increases by 3% each year. We want to write a function that represents the number of bunnies after X number of years have passed. This is not asking us to solve. So A, do not solve. This is asking you to write a function. We need to figure out if this is going to be a growth or a decay function. Because we are increasing, this is going to be your growth function. And they want you to use X as the number of years. So number of years represents the time. So instead of writing T for time, they're going to ask you to write X for time. So let's write out our exponential growth formula. Y equals A times 1 plus R to the T power. So what's our starting amount? We are starting with 350 bunnies. What's our rate? We need to convert this as a decimal. And our decimal is going to be 3%, 2 decimal places to the left, which is 0.03. And we have our time, which is x. And the reason I'm using x instead of t is because that's what they're asking for. Now, two things. You can leave it like this. I will give you full credit for this. This is fine. Or you can type this into the calculator and write that number as 1 plus 0.03. Oops, that's a 6, not a 3. And then write this number in. I'm going to leave it just because I'm too lazy to erase it, but you can just write this number in here. That's fine. Find the population after 7 years. So now they're telling you how much time has passed. So we're going to put this into the calculator exactly how we see it. Except now instead of x or t, we're going to write 7 for 7 years. So I'm going to open this up. 350 times open 1 plus 0.03 caret right here, 7 equals, and again, we're talking about number of bunnies. We can't have a bunny just a leg or just an arm, so we're going to round to the entire whole bunny. This is a 4, so we're going to round down technically, and so we're going to keep this as 430 bunnies. Make sure that you are telling me what you're talking about. Are we talking about fishes, children, bunnies, money? What are we talking about? We're talking about bunnies. Next, we have Sammy has $500 in her savings account. Her savings account balance will decrease by 3.4% each month. Write a function to represent how much money Sammy will have in her savings account after X months. So it looks like we're spending some money in a savings account. Should be a savings account. We should not be touching that money, but you know, everyone has their own life. So let's start with, is this a growth or a decay? Since we're decreasing, this is going to be a decay function. Y equals A times 1 minus R to the T power. How much money is Sammy starting with? 500. We are decreasing, so we need to convert this to a decimal. 3.4%. 1. 2 jumps to the left. So we have minus 0.034. And did they ask us to use, yep, once again, X for the month. Okay. So this one, be careful. This one, they were talking about how much years have gone by. This one, they're talking about how many months have gone by. So each month, she's spending some money out of her savings, which she shouldn't, but, you know, whatever. All right, if no other changes are made, how much will be in the account after 1 year? Now, I've bolded this for a reason. Be careful. The equation that you have created is for months, but it's asking you how much money will she have in a year. So 1 year, when we are talking about months, means it's not going to be 1 as your time. It's going to be 12 as your time, because in 1 year, you have 12 months. Now, this is not compounding. I know we're going to have a formula for compound interest. This is not it. This is just them using different quantities of time, 1 year versus 12 months. So if they're giving you a percentage in months, you have to convert the 1 year into months. Now, let's go ahead and type this into the calculator. And I'm typing it in exactly how I see it. So if she keeps using her savings account money, she's going to end up with $330. And be careful. Here, I am rounding money. Money is 2 decimal places, but I'm also looking at this 8. We're going to round up because 8 is bigger than 5. So we have 14 cents is going to be left. So she starts out with 500. She's going to have $330.14 left. Let's go ahead and move on to question number 10. Question number 10, it says, write a function that represents the balance. A 2,200 deposit that earns 7% annual interest compounded monthly. So here's that word I just mentioned, that compounded monthly. Compound means we have to use the compound formula. So it's a completely different formula than growth and decay. Has some similarities, but so we have A times P times, or I guess not times P, let's try this again. A equals P times 1 plus R over N divided by, we're going to put that in parentheses, raised to the N times T power. So they want a function, so they want an equation with T. So they're not telling us the amount of time that has passed. They're telling us we want to keep as T. However, they are telling us that it's going to be compounded monthly. So compounded monthly means it's going to happen 12 times per year. So that means our N value is going to be 12. Annual interest rate is 7%, means we need to convert it to a decimal. And we have our initial deposit, which is going to be our principal, at $2,200. Let's write out our formula. We have Y. I guess not, it's not Y now, it's A, right? So let's keep it as A equals $2,200 times 1 plus our rate of 0.07 divided by 12 raised to the power of 12 times T. Now they do want us to keep it as T. Again, I am okay if you leave it like this, but to be more accurate, we want to type this into the calculator. Double parentheses here, so watch what I do, please. So I have 1 plus 0.07 divided by 12, close it, close it. Technically, we want to write this, but it's a decimal, so I would prefer you to keep it the way that it is. Don't type anything in, type it in after we actually want to calculate. If no other deposits, withdrawals are made, calculate the amount of money she will be in there after 12 years. So we're taking this formula, writing it out. Extra parentheses, be careful here. Close it, caret. Now we want to put this in parentheses as well when we are typing this into the calculator. We have monthly compound, so this is N, and we want 12 years, so this is our T. We're going to type that into the calculator exactly how we see it. Oh, let's see, make sure you guys can see it. We got 2,200 times open, 1 plus open, 0.07 divided by 12. Close it, caret, open, 12 times 12. And again, that just happened to happen. 12 for monthly, 12 for the number of years. And again, be careful with someone's money. We want to round accordingly. 5083.585. And because we have a 5 here, that means we're going to round that 8 up by 1. Money symbol. So if she deposits $2,200, we don't know if it's a she or he, but whatever. If they deposit $2,200, after 12 years, compounding monthly, we have $5,083.59. All right, let's move on to the last two. These are some possible extra credit questions. These are questions that are from chapter 5, so the previous chapter. Let's go ahead and do question number 1. Question number 1 is asking for you to use elimination. Any other method will receive no credit. We're going to choose two variables. I have an x and an x, or I have a y and an y. And I'm noticing that none of them, my numbers are the same, which is a shame. I have 10 and 6. I have 8 and 9. I'm going to choose x's, so I'm going to multiply everything here by, not by 2. I'm going to multiply everything here by 3. Now, the reason I'm going to choose to multiply everything by 3 is because in my brain I'm thinking, what number does 10 and 6 have in common? And that number happens to be 30. I'm going to multiply this by negative 5 on the bottom because then I can make it 30x plus 24y is equal to 12. Here I can make it as negative 30, so we want opposites and same number, negative 45y, and a positive 30. Same number, opposites is our goal. We're going to be adding to eliminate the x's. So the x's are going to be gone. I have 24 and a negative 45, which gives me a negative 21. Y, dotted line. 30 plus 12, I get a 42. Divide both sides by negative 21. y is then equal to 42 divided by negative 21, which is a negative 2. I'm going to put this in a thinking bubble because this is not our answer. Choose one of your originals. I'm choosing this one just because I have space near it. I'm going to open up for y, and I'm going to write my y value of negative 2 in this bubble. When you do that, you're going to have to evaluate, multiply these two together before you continue. So we have 6x minus, now because this is negative 18, I'm going to set my calculator so I can hold my paper. Dotted line, I'm going to add 18, add 18. 6 times x is equal to negative 6 plus 18, which is 12. Divided by 6, x is equal to 2. Oops, dotted, not dotted. A thinking bubble because this is not my answer. We're going to combine our x and our y together to form our final answer of 2, 2. And we're reached at the end. Thank you so much for bearing with me as we go through these questions. Graph the following inequality, shade the true region. So notice this is not in slope-intercept form, so you have two options. You can either do intercepts, x and y intercept, or solve for y. I vote to solve for y. Dotted line, I'm going to subtract 3x, bring down the 2y. Now this is a positive 2y, so be careful if it's negative. Sometimes you will need to switch the sign. Here it is positive. Divide by 2, divide by 2, divide by 2. Because we are dividing by a positive 2, keep the original inequality symbol. And now we're ready to graph. This right here is our y-intercept of 0, 2. This is our slope of down 3 over 2 to the right. So let's start at 2. Here's the 1, 2. Down 3, 1, 2, 3 over 2. 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 Hold this better. And then opposite direction, 1, 2, 3 over 2. 1, 2, 3 over 2. And here we are. Something seems off. Let me try counting again. We're here. 1, 2, 3, 1, 2, 1, 2, 3. I knew something was off. 1, 2. That looks better. All right, now I don't have a ruler on me, so I'm going to use just a side of paper. Because we have the or equals to here, we want this to be a solid line. So I'm going to connect these as best as I can, which is something's going on with my numbers again. Let me see if I can count better. We want 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. I was a little bit off here. So I'm glad I was testing with my paper. There you go. Now we can do a straight line. It is going to be solid, so I'm going to connect these to the best of my ability. Doing an arrow. All right, now that we're here, we need to shade in the true region. So we need a testing point. I usually go with 0, 0 as my test point, just because it's easiest to calculate. I'm going to separate out some space. And my test point is going to be 0, 0 for my x and my y. Take your original, open up for x, open up for y, and see 0 plus 0 if this gives you a true or a false statement. In this case, 0 is smaller than 4, so we have found our true region, and we're going to shade that in. Make sure you do not give me scribbles. I want smooth and clear lines, so that way I don't have to guess where your shaded area is, and that way it doesn't look like a hot mess. All right, beautiful people, thank you so much for watching. That is it, and I will see you in the next video.